This screencast is for AP Chemistry, and we're going to talk about solution stoichiometry. So we're all warmed up with going from grams of one compound to grams of another in a chemical reaction. Most of the time, though, when we work with substances, they're not always in, or they're not in the solid form. We deal most of the time with solutions. And if we're going to deal with a solution, there are certain things that we have to know. And one of those would be its concentration. Concentration would be in terms of molarity, or how many moles per liter we have. So molarity is equal to moles of solute over liters of solution. And so anything that has units like this is going to be a conversion factor. And just like we do with density, we can use molarity to convert from moles to liters or liters to moles, as long as we know its concentration. I have a problem here. How many grams of magnesium hydroxide will precipitate if I have 25 milliliters of a 0.235 molar magnesium nitrate, and that's combined with 30 milliliters of 0.260 molar potassium hydroxide. So we're reacting two solutions here. Take a minute, pause the screencast, and try and write that reaction. So magnesium hydroxide, remember your charges. Magnesium's in group 2, so it's 2 positive. Hydroxide is OH negative. So we want to know how many grams of magnesium hydroxide will precipitate if I react magnesium nitrate. So magnesium and nitrate, that's going to be MgNO3 2 plus potassium hydroxide. Potassium's in group 1, so it's KOH, yields, and they tell us that it is going to produce that magnesium hydroxide, MgOH, inside parentheses, don't let hydroxide get you, 2. There's another product there as well. You can tell this is looking like it is a double replacement reaction, and it can't end here. Even though they make no mention of it in the problem, you must complete the reaction. The potassium just can't disappear, so the potassium is going to combine with the nitrate. So it's just going to be KNO3. Now this one ends up being pretty easy to balance. I like to look at my polyatomic ions. I've got one NO3 and I have 2 over here, so I'm going to put a 2 here. That changes my potassium to 2, so I'm going to need to put a 2 here. That gives me 2 hydroxides, and I have 2 hydroxides. So now we are balanced. Now let's extract some information out of the problem. So we want to know how many grams of this are going to be formed. I have 0.235 molar concentration of this, and we're going to use 25 milliliters. Then in this one, we're going to have 0.260 molar concentration, and we have 30 milliliters of it for them to react. Well, we have the given amounts of 2 reactants. That means we are going to have to find the limiting reactant. Okay, so here we don't have grams, but what we can very easily find from this are the number of moles. And in honors chem, we use the little triangle, and molarity is moles over liters. So if we're looking for the moles of these, if you take molarity times liters, you're going to get your moles. And that's really a good strategy to have in AP chemistry, is that if you can convert something to moles, or if you can write a chemical reaction, all of those are going to be very helpful things that will probably push you along the right path. So I need to find my moles, but notice I have milliliters here and not liters. So I need to convert all of these to liters, and we're going to move the decimal over 3 places, both of these. And those are our liters there. Okay, so if I multiply these molarity times liters for my magnesium nitrate, I get 0.00588 moles of magnesium nitrate. And for potassium hydroxide, 0.00780 moles of potassium hydroxide. That gives us a place to start, and now you can figure out your limiting reactant and the amount of product produced. So I'm going to start here, and I'm going to show you a little shortcut on how, since we're working with timed assessments, on how to go about finding the limiting reactant quickly when you can. So if I start with 0.00588 moles of magnesium nitrate, and I use mole ratio to go to my magnesium hydroxide. It is going to be, for every 1 mole of magnesium nitrate, I have 1 mole of magnesium hydroxide. Now, I'm going to stop right there, and I'm going to go ahead and start with this amount of potassium hydroxide. So 0.00780 moles of potassium hydroxide. And we're going to do the same thing and go to magnesium hydroxide. So 2 moles of potassium hydroxide, because of our coefficient here, is 1 mole of magnesium hydroxide. I'm going to have to take this out to grams, but from this point right here, I can already figure out which one is going to produce the least moles of magnesium hydroxide. This number isn't going to change. This number is going to be divided by 2, so it's going to end up being the smallest. That way I know that my limiting reactant is potassium hydroxide. So this is the problem I'm going to choose to finish and find the grams. So I just used moles to figure out which one was a limiting reactant, just to save me a few minutes, because the next step would be the same for both of these problems. So we just have to use the molar mass of magnesium hydroxide, and it is 58.33 grams of magnesium hydroxide in 1 mole. And so what we end up with there is 0.227 grams of magnesium hydroxide, with potassium hydroxide being our limiting reactant. So this would answer that question.